my Chris. Okay, man. You okay? Have you guys done this part? Not yet. Anybody who hasn't done? Or who has done? Done. Let me show you how to, if you haven't done it. No, let me show you how to do it. It's based on stuff we did in the class, in the lectures. Alright guys, so question 6, part 1, right? So you have a variable x that has a normal distribution with these parameters. Now, one of the properties I gave you in the class, in the lectures, was the following: that if x has this, what distribution will this have? is the normal with parameters 0 and 1. This is one of the properties I mentioned in the class. You remember this or no? Yeah. So what this implies is that the CDF by definition, this is the CDF of X, and this you can write as this, right? You see what I've done on both sides. Now, on the left hand side, you have a standard normal variable, and on the right hand side, you have this. Right, and this, you know the notation for this, the CDF of a standard normal variable, phi. This is the notation for the CDF of n01, right? So this would be where phi okay. It's not difficult, is it, guys? It's just using this property here, which I mentioned in the lectures, right? Okay. Any questions on this? You okay, man? You okay, guys? All right. Part 2 of the same question is asking you to find the quantile function. So let me take this away. So this is question 6. Question 6, part 2. Now, the quantile function at P is defined by this following relation, that x less than equal to qp is equal to p. So it's the value for which the probability that x is less than equal to this is p, which is the same as saying that the CDF of x at qp is p, okay, because this is the definition of the CDF of x, right? Now from part 1, we know that this guy we can write as capital phi okay. That's from part 1 of the same question, right? And this implies that Q of P minus mu, you should take the inverse function both sides. Right? And this implies that Q of P is equal to mu plus sigma. So this is this guy here is the is the quantile function of a normal variable, right? So to find the quantile function of any distribution or any variable, you need to start with this step and then try to solve for Q of P, right? So this procedure is the same for any distribution, and here we've done it for the normal. Okay? Is that clear, guys? Okay. Now, is the part 2 is also asking you to find the formula for the IQR. Do you guys remember the IQR or the interquartile range? What's that? I just there's no need to take photos, guys. I'll post this online. Remember, IQR is, what's the definition of IQR, guys? I mentioned in the class. Yes. Exactly, yeah. This is the definition, right? Now Q at 0.75 is mu plus sigma phi inverse at 0.75. That's from this statement here. Okay, by star, call this star. Okay, and Q at 0.25 is mu plus sigma phi inverse 0.25, again by star. Right, so this implies that IQR is sigma right, and you can read this gap from the tables, the normal table which I mentioned a couple of weeks ago, a week ago or so. So if you read this, you will get 1.349 times sigma. Alright, so that's, is that clear, guys, or no? You okay? Can you guys do question 2 now, please, if this is okay? Question 2. Question 2 is this one here. Question 2. So here is asking you for the 5-number summary. The 5-number summary is basically the following: is the minimum, the first quartile, the median, the third quartile, and the maximum. So basically these 5 numbers, form the 5-number summary. All right. Please make sure that everybody signs the attendance sheet. All of you signed it or what? You haven't? Oh, you're signing it. You have to make please. Chris, have you signed? No. Thanks, Chris. Anyone else who hasn't signed the attendance sheet? Okay. Can you do question 2, please? Everyone. Good. Good. Alright guys, so let me if you haven't done it, I know this question is trivial, it's not difficult. So this is question 2, part 1. Right, so the 5-number summary is the minimum first. The minimum is just the smallest data point, which is what? Which is 29.14, right? And then the first quartile, which you want, is Q 0.25. So for this, you will use the formula I gave in the lectures. So your P is 0.25, and your N is 20. So your R is P times N plus 1, which is 5.25, and your R prime is the integer part of this, which is 5, right? So your Q at 0.25 is X sub 5 plus 5.25 minus 5, then X6 minus X5. Right? This is the formula, right? You remember this? Yeah? So if you work this out, you get 37.0325. Yeah? So that's the first quartile. Now the next is the median. Remember, I gave you a formula for the median, which is it's depending on whether n is an even number or odd number. In this case, it's an even number. Do you remember the formula? Right. The formula is the following. If you don't remember, I'm an old man, guys. I can remember the top. You guys should remember this. You remember this formula? This is the formula when n is even, right? Okay, so now n is 20 in our case, so this would be half of x10 plus x11, right? And if you work that out, you get you will get 41.186. So this is the median, right? The next one is the third quartile, which is Q at 0.75. So your P is 0.75, your N is 20, so your R is P times N plus 1, which will be 15.75. Okay, so your R prime is the integer part, which is 50. Alright, so your Q is gonna be, if you use the familiar formula, you get X sub 15 like this, right? And if you work this out, you will get 44.01. Right, this is the third quartile. And finally, the maximum is just simply the largest value. The largest value is 51.261. Alright, this is clear to all of you now. So it's just the pi numbers you need to compute. The minimum, the first quartile, median, third quartile, and the maximum. Okay? Alright, that's part 1. Part 2, well, let me take this away. You don't need to copy our scan and put online. Part 2 is the following. Part 2 is asking you to find the mean and the standard deviation. So the sample mean is x bar, which is so you sum all the 20 numbers and divide by 20 to get the sample mean, which will be this, right? Okay, guys, this is what you got, yeah. And the sample variance remember, I gave you two formulae for the sample variance, and here I'm going to use the unbiased version, because the unbiased version is, as I explained it this morning, is better than a biased version, right? So I'm going to use the unbiased version. The unbiased version, and if you work this out, you will get 30 point. This is what you get, okay? And finally, the sample standard deviation, or sample SD for standard deviation, is simply the square root of this number which is 5.527. All right, are you okay with this, guys, or not? Yeah, all right, that's part 2. Now part 3 is asking you part 3 is asking you to do a table. Alright, can I take this away? Okay. It's asking you to, this question 2, part 2, okay, part 3, I mean. So you have basically in three columns in the table. Alright, the question reads as follows. So you have equally sized intervals of length h equal to 5 in the range 25 to 30, right? So the intervals will be what? So the first interval will be from 25 to 55, yeah? So the first interval will be from 25 to 30. Alright, so these are the intervals, and in the frequency column you just count the number of data that fall in each of these intervals. Does anyone, I mean, that's easy to do, right? It's not, you just count how many of the data. So between 25 and 30 there's just one data point. Between 30 and 35 there are 2. 35 and 40, 5. 40 and 45, 8, and 3 and 1. So this is the frequency in each interval, right? And the density is, to find the density, what you do is you divide each of these by the total number of data points, which is which is the total is 20, yeah. But also divide by the length of each interval. The length of each interval is 5. Alright, so you have to divide by 20 times 5. You have to divide by the total number of data multiplied by the length of each interval, which is 5. Okay, so alright. So that gives you the density. Okay. Okay. Now that's question part 3. Now part 4. You guys okay so far? Any questions? Part 4 is asking you to draw the histogram. So the okay, before I go to part 4, the histogram the histogram is basically what you do is you plot the density column on the y-axis and the interval column on the x-axis, right? And what you will get, because I'm lazy to plot, what I have done is just to draw it on the computer. So you see this is the interval column, this is the density column, right? And you get a picture looking like this. You can do this in R, right, using the hist command, So if you want to do this in R, you just type in hist in brackets x. X will contain the 20 data points, right? Okay, so you do that. Right? That's what you would do. You could produce something like this. Okay. All right. Now, part 4, question 2 is asking you, what is the shape? I mean, what kind of shape you have here? Come on, guys, talk to me. What kind of shape does it? How does it look like? Approximately.
Symmetric.
Alright, guys. So we're done. Any questions, guys? Can you do question 7, please? Question 7. like semester. Okay. Can you guys do question 7, please? 7. Yeah. Yes. You need to consider the case of M7 and MSR. So you need to consider, yeah, 2 cases for M7. Then you will know what to do. Okay. Oh, sorry. No. Guys, can you give me some space? Can you give me space? Yes, ma'am. What's the question? Yeah, you need to divide by the total data points, which is 20, and also the length interval. So, because otherwise, the reason I divide by 5 is because otherwise the area will not be 1. You see, the area below the area of the curve, so of the histogram, must be 1 by definition. Right? That's the reason I divide by 5. But if you don't divide by 5, the area will not be 1. Yeah. You should plot the frequency on the y-axis. It will not add up to 1. It will just plot the frequency only. But you should have the density. If you want the density, you need to divide by 20 and also the length of each block, so that the density is 1. So the area below the density is 1. Yeah, they need. Otherwise, you cannot get density. Sorry? That's because any density, I mean, you must have done in probability 1. Any density must integrate to 1. So that's why the area below that must be 1. Yeah. Yeah, that's a very good question, guys. Yeah. See, the reason I have divided by 5 in the table I showed you earlier. In this table, where is it? Here. in this table I have divided by 20 and also 5. The reason I have done that is because if I don't divide by 5, the area below this histogram will not be 1. You see, I'm sure you know from probability 1 that any density, a property of any density is that it must integrate to 1 or it must sum to 1 if it is discrete. All right? So that's exactly why we divided by 20 and also 5 the length of each bar, right? Otherwise, we should add up all these, the area of this area plus this plus this plus this. It should be 1, right? All right, guys. Next, question 7, which is easy, which is, I'm sure all of you did quiz 3, right? Question 7 is easy, right? So you just need to consider the cases where n is, okay, let's consider the case n is odd. We know that p is a half. So your r will be n plus 1 divided by 2. Your r prime will be, and this will be what? Because n is odd, n plus 1 is even. So even divided by 2 is an integer, okay? So this is, so q half because this guy here is 0, okay? So this becomes, sorry, I should say x. Okay? You follow me? Yeah? Now, n even. N is even, r is still n plus 1 by 2. R prime is the integer part. Now, n plus 1 will be an odd number. So the odd number divided by 2 is not an integer, it's a fraction. So what's the integer part of this, guys? What would this be? n over 2. Yeah, exactly. Okay. All right. So q at half will be like that. All right. It is. Which is this, and this can be simplified to half right, guys? Are you okay? It's not, I mean, since you've done quiz 3, it shouldn't be difficult for you after you. All right. Solutions to all the example classes are online in my website. So if you want to check your answers, yes. Well, you know the course website, I'm sure all of you know. Just go online and check the answers online. Okay. Alright, I'll see you guys whenever. If you've done quiz 4, can you give it to me please? So I can start marking. Okay. Thank you guys. Have a good day. Okay. Good, you okay? Have you done your essay? You want to show it to me later or what? Yeah, you can email it to me whenever. Okay. Yeah, I'm in my room until 6 today. Just drop in if you want to talk. Whenever you want to talk, just drop in.